Okay, so today we're talking about animation. We'll have an overview of a simple workflow that should get you started for like a small indie game. Obviously, what I have in mind here is your final project assignment. So hopefully a couple of tricks today that might help you get started, add a little bit of life to your project. Some topics again, so animation, just a broad overview. Then I'm going to do a quick character sculpt in Blender. You're welcome to try to follow it or not. Not sure if you have Blender ready to go, but mainly it's to show you some of the things that you normally don't see in Unity, such as specifics of things like armature, skeletal animation skeletals, and skinning, so weight painting. Then we'll pull it all into Unity and work a little bit with Mecanim, which is the Unity animation system, which is basically a way to design state machines. So states and transitions between them. It's like a flow chart between different states, and then we'll also look into doing some animations without using a animation package or Mixamo, just straight from Unity by recording to timelines and seeing what's happening there. Yeah, so animation is it's a very broad topic, and if you just look at some of the keywords I've thrown in, there's a lot of jargon around it. Well, like with any discipline related to game development, I mean, the people, you can have a career based on just animation itself. So let me fire up Blender and let's make a simple humanoid. Okay, where do we start? Now, I don't know, some of you might be more well versed with Blender, some of you less, but I think there should be interesting bits for everyone along the way. So let's start with a cube. I'm just making a small cube. Alright, and let me move it. So I'm pressing G key and Z key, which locks me to the Z axis. I'm moving it up by 1 unit. Okay, and let me unfold this. This shows me about the general location and size of the object. So now I see that I have dimensions 2 by 2 by 2, which I should assume, if we do our export to Unity correctly, this will be meters. So Z is 2, that's fine, we can live with that. But I don't like the width and depth of it, in this case the Y, so how about we scale it Y, I'm gonna scale it by half, okay, and scale X also by half, and this is still kind of too thick, so I'll scale, let's see. Just make sure I'll switch to front view. Okay, so that's front view. So now Y axis is the one which I'd like to scale down 0 to 5. No, scale Y 0.5. Okay, so that's my kind of starting point. Everything clear so far? Now you don't need to necessarily use Blender. I'll show you a simpler alternative later, but I think it's good learning as a game developer to at least know how to make some very low poly characters. So bear with me. I'm going to go to edit mode now and switch to select edges. So deselect it. Let's go wireframe. So this is where I can switch to showing just the lines. And I'll use the B key on the keyboard to select just border select. So with border select I can just select something using a kind of a drag motion. A key allows me to select everything or deselect everything. So again, border select. Okay, I've got a couple of edges selected, and now I'd like to go to edges, subdivide them. I just want it subdivided by half like this, which is I'm happy with that. And now border select again, and let's go again, do the subdivision. Let's subdivide it into 4 and see what happens. Or actually, yeah, 4 works better. Let's go with that. Let's work on arms. So I'm switching to face select here. So now I can just work with faces. And I'm using the extrude function. So press E on the keyboard and then 0.5. And this extrudes the face, creates a bunch of other faces along the normal. Quick question. What's a normal? Anyone? No? Okay, well, normal is a vector which defines the direction that a face is pointing. Also, sometimes you might have normals stored with the vertices. So vertices, but a little few words about geometry. In Blender, for example, you're dealing with vertices. So here I'm selecting different vertices, basically points. Then those vertices can be connected, creating edges. And then vertices and edges coming together create faces. These can be quadrilateral or they can be triangles. In terms of game development and the geometry that your graphics card processes, it's usually triangles that you deal with. But it is possible to work with other primitives too. Like you can render with lines, for example, or points. So your graphics card, depending on what generation, it can usually work with that as well. But that's another topic. So now let's continue with our hands extrusion. Extrude 0.5. Okay, and once more extrude 0.5. So you can see this is a rough template for a forearm, an arm. Right, and this is going to be our head neck, so I think, yeah, let's move this a bit. So grab X minus 0.5. Did I overdo this? No. Grab X minus 0.5. Yeah, I did. Okay. Minus 0.25. Just a little nudge. Grab X 0.25. This could be our head, but let's make it into just a neck. So I'm going to select these two faces, grab them, and just move them down the Z-axis a little bit. And then I'm going to extrude it again a little bit. It's going to be our kind of chin. And then I'm going to extrude it again. And this will be our actual head. So let me show you a front view. So let me just select the vertices or edges, or it actually doesn't matter, we can go with edges. I'm going to border select, so B select, and I'm going to make sure that my scaling center, the pivot point, is median point, and I'll scale it from here. So let's make it bigger, maybe not so big, and again grab and move it up a little bit. So we have a very kind of crude, rudimentary head there. Should we leave it like this? Yeah, I suppose it's gonna be cute to see anyway. So okay, so let's see. Time for legs. Or maybe before that, let's do something with these arms here. Border, select this, grab X, let's see, 0.25, no, that actually is okay. I'm using A again to select, deselect, border, grab X, 0.25, so I'm just moving by 0.25 units there. I'm gonna do this here as well for the grab. Oh, sorry. Need to be careful what you leave selected, because I was just gonna do this for too many faces. Grab X minus 0.25. Okay, so that's kind of like the beginning of arms, and now let's extrude some legs. So face select, deselect all. Let me switch, because this is maybe not the best view. Let me just switch to normal solid view. Select this face, extrude 0.5, and again 0.5. Okay, and let's make sure that the legs are separated just a little bit. So view front. Okay. Grab X and just move it very, very slightly in this direction. Okay, I made a mistake here, which was I didn't have limit selection to visible. I had that selected, so this limits the selection to only the visible faces. So that's not what I want. So border, select, and now we see that it selected everything on all sides. View front, and just want this actually. Grab X and just move it slightly so there's a separation. Okay, and now let's do a similar thing here. So extrude 0.5. Okay, extrude 0.5. And as simplistic as it is, it should do the job. So again, border, select. Okay, grab X and just move it a little bit. Okay. Alright, I think our proportions are still a little wonky, so I'm going to select edges. And move this up a bit, grab Z, and just do this, doing this kind of manually now. Okay, just to have equal density now, I'm going to move this as well. So this is where we kind of like start going into topology. So 3D artists would spend a lot of time learning how to properly topologize their mesh so that it has the right connections between faces and the right overall flow, because then you can start texturing it easily, and then maybe you need to make sure that the number of polygons is manageable. So okay, I think I have like a general outline there, which should work. Maybe I'm gonna just push up the chest a little bit. Deselect border. So only using a couple of tools there, it's nothing that complex. Grab Z, and that's something I think we can live with. So view. Apologies if some of you are much more accomplished 3D artists than I'm probably making you cringe now, but grab Z, and I'm just gonna recenter it so that it's standing on the floor. So okay, let's have another look here in object mode. What final size we ended up with? Oh, this is 3.5 meters, so not what we want. Let's scale it then. Let's go down to realistic height, 1.7 meter. We can live with that. And grab Z, bring it down again. Okay. Let's have another sanity check. If I go again to wireframe mode, let's have a look. I see that I have something weird happening there. This probably means that there are some duplicate vertices. So I'm going to edit mode again, where I can interact with individual vertices and edges of the mesh. Mesh, vertices, remove doubles, and see it removed for the vertices. And if I go back to object mode, I see that the model looks a little bit better. Any questions so far? No. Okay. All right. So let's do something to make it look a little bit better. So modifiers in Blender, tools which you can apply to the whole mesh. You need to be in object mode to do that. This is the modifier tab here. Modifiers, add modifier, subdivision surface, bang. And right out of the box we have something that's much more palatable. Catmull Clark is the type by default, and now let's make sure that we have this set to 3, view and render, and I think I'll be happy with that. Maybe we could punch it up one more. I don't know, that might be actually too much. Yeah, let's go with this. It might be a little bit extreme. Like when I look at the number of vertices, this is 18,000. So this is quite a lot, to be honest. But yeah, okay, I'll bring it down. I won't be so wasteful. So now I'm at about 5,000 vertices, so it's something we can live with. Let me bring this whole thing down again so that it touches the floor. And let's have a look now at the overall location, rotation and scale. So you see that we have a scale which is non-1. This means that the root node already has a transform applied with scaling, which is something you don't want to do if you're exporting to Unity. So what you do in this case is press Control A, and that allows you to apply this. So apply rotation. You see that this zeroed out. Then Control A, rotation and scale apply. So this actually applied all this scaling to the actual mesh. So the scaling is already contained within each individual vertex position, and the whole thing is just basically at scale 1. This is the original scale of the mesh, which is what we want. Another problem now is this is kind of very blocky now. Is this maybe something you want to for your specific low poly style, but in this case, yep. Yeah, so if I didn't do that and I imported this to Unity, then my original root node, like if I import this model, would already have this transform on it. So the mesh itself, if I drag the mesh onto a new node in Unity, it would be deformed. It wouldn't have that scale applied. It's a kind of like a lowest level transform that's applied to the whole model. So you can experiment and you know, try to export something, a cube which you flatten first, and export it to Unity and see what the base mesh is. So you'll see that the base mesh in Unity then is going to be still a you know, equal-sided cube, but the only the transform will actually apply and squash it. But in most cases you don't want additional multiplication or additional kind of matrix multiplication to be happening when you don't need to. So by applying, I'm actually flattening or baking this mesh into this right scale right away. So the scale, when it's at scale 0, 1, those individual vertices positions, so if I go here, let me actually try and see how that works. I'll go back, Control Z. I went back, my scale is still something, yeah. And let me go into edit mode. Okay, I haven't applied the, first of all, I haven't applied the modifier. So let me apply the modifier. This, first of all, bakes it, because right now this is still, the modifier is still fluid. I can still adjust the parameters of this operation. But I'd like to eventually freeze it and apply it and forget that there's a modifier. So this is what I did, applied the modifier, and now I can access individual vertices. Let me go to vertex select. And you see this is a vertex here that is now at this position, 2 minus 0.78, 2.44. Okay? This is the number that I get for this vertex now. Or maybe let's pick something that we can find easily later. So this one on the top of the hand, yeah, okay, so I'm selecting this one. It has a large X because it's the right hand. And so remember this number, 338. I go back to object mode. I apply the scale, Control A, let's say location, Control rotation and scale. Go back to edit mode. And now this vertex is now at 0.82. This is the original vertex, location of the mesh. The mesh didn't, in world space, the mesh didn't change. But what changed was the overall scaling of the whole model. So ultimately we want this to be at 1. So I hope that answers it. It's something that you'll eventually run into, especially with rotations, because with export from Unity into different coordinate system, you will run into some issues unless you're very careful. Okay, let's continue. Okay, we've got that applied. Another thing I don't like now is that it's all blocky, like I said. Let's have a quick look in edit mode again at the normals. Again, is the concept of normal something you've encountered before? So now we can see this. These are the normals for the vertices. These are vertex per face, vertex normals as lines. These are face normals. So depending on the type of shading, you might need to store extra vertices. So in this case I have 4,610 vertices. Let me see, if I go to shading UVs and I make the whole thing actually sharp edges. Okay, and shading flat and vertices sharp. Okay, let me see what did that change anything? Okay, calculate set from faces maybe. Okay. Maybe I didn't do the best demo of this, but in edit mode you can access here the shading UV. So by going to smooth here on faces, edges and vertices and recalculating it. Okay, I messed it up, I think. So that's where we have undo. Before I started messing with the UVs, right now I have faces smooth. Okay, and now I have a smooth mesh. So the shading changed because because now the vertex normals are kind of in between. They don't match the face normals. They are in between. This allows for kind of transitions that make rounded like shapes for lighting. Okay, one last step there is UV mapping. What's UV mapping? Just in just the gist. Have you heard about UV mapping? In a way, yes. It's additional information that you add to the mesh, to the geometry, especially to vertices. So you store a coordinate in a vertex, each vertex. So let me select all the vertices and just use let's be lazy, let's UV unwrap it, and Blender has smart UV projecting, which allows you to just unwrap it automatically. It's not the best unwrapping because you see it did weird things to the scale, but this is something that your artist can already start working with and painting this over. I'm not gonna go to material flow in Blender. I mean, if anybody's interested, I can maybe point you to some tutorials. You'll be able to find something on your own. But what you see is now that for each individual vertex, let me select a face. So this face corresponds to this little bit on this square image texture. So for example, if I create a new image, in this case, a color grid. Alright, okay. Because I already have the UV coordinates there, let me just go really quickly. Okay, there might be a couple of things happening there. Let me just quickly point light. So no, it's not the lighting, it's probably the material. So I'll go here. Okay, texture, new. Cancel. Okay, bear with me, just a second, I didn't have the right node selected. So just make a new material. Yes, okay. And add a texture to it. Map is the UV map that we've just created, so let's, yeah. Okay, I admit I haven't done this for a while, especially in Blender, so I can use an entitlement mesh here, so that's the material. Okay, so this should be the right material. Assign, okay, and why am I not seeing it? So if I render it out, I see the correct material. You see the UV mapping is pretty crummy. And texture, okay, yeah, good. So maybe. Okay. Okay, back on track. So as you see, the texture mapping that's going to result from this is a little bit crummy. What happened there? Actually, if I go to okay, if I go to edit mode, you can see those individual. Oh, sorry. Oh, thank you. let me start again. I think the order in which I launched. Alright, back online. Okay, so what happened here is that the smart UV project, you kind of depends on angle criteria to do the unwrapping, and it just decided to cut these meshes along those lines. What an artist would do normally is create a topology, would specify certain edges to be the desired ones, where we would like the texture to tile, or we would like the piece of texture to end. So in this case, maybe I'll just do a front view. Maybe in this case it might make more sense to do a project from U bounds. This creates a very simple mapping where it unfortunately covers both front and back, but maybe we don't care about it. This is a quick way to maybe texture something. Another way would be to maybe select front and back separately and unwrap it separately. But anyway, that's not our main focus today. So let's just export this, because I think we're happy with the model as it is. It's UV mapped, it's smooth shaded, it's got the right scale, and the scale has been applied. Oh, actually no, something changed here. No, the scale. Yeah, we need to apply the scale. Okay, and I'll do the export to FBX, because while Unity would support blend file, it's the native Blender format, that would assume that any other dev would have Blender on their machine, and then you have problems with different versions maybe. Or if there's no Blender installed, then suddenly half of your assets are missing, so there's a danger in that. FBX is one of the kind of industry standard, interchange formats that is often used. So I'm going to just export it straight into the project that we've created. So git animation project git. Yep, that's what we called that. Into assets. I'll make a new folder, models. You don't need to do that because you just import the package I gave you. But this is our original character. So character. And when I'm exporting, important to click this experimental apply transform. There's a couple of settings that are kind of the default. Yeah, okay. However, this checkbox is your friend in general if you're exporting to Unity. Anyway, hopefully we won't run into any major problems. Let's go to Mixamo now. So Adobe Mixamo is a solution where online tool, which uses machine learning to do the rigging of your geometry for you. Okay, this is another thing that I'm going to mention to you, but let's upload this FBX file which we just created. To use it, you need to create an account with Adobe, but it's free to use, and those animations are also free to use. As far as I know, there's no licensing issues, but don't quote me on that. Assets, models, character. Let's import that. Okay, auto rigger lets us rotate the model in case we don't have it facing the right way. So we're happy with that. Now we need to pre-select some markers. So okay, this is the chin. Okay. Okay, sorry about that. Hopefully back on the road. Okay. everybody online? Okay, okay, so back to Mixamo. Okay. We need to assign the markers, so now elbows. It's all cute to see, so we don't really care about precision so much. Okay, knees and groin. Okay, next. So now through the magic of machine learning and artificial intelligence, our model is analyzed and a skeleton gets created to it. So this is the process known as rigging. Might take a few minutes while we wait. Maybe let me give you a quick spiel about rigging. So what's happening is that a skeleton gets created, which is a hierarchy of bones, rigid segments which are connected to each other, or some of them might not be necessarily directly connected. So if I move this bone, I would expect this one to follow along with this one, for example. This allows us to do complex human-like animations. The next step that's happening is that you see that you have the skeleton, but you also have the geometry, your actual mesh which you've developed. So how do we actually map from the skeleton to the mesh? That's another topic. Obviously Unity eventually, or whatever is playing back the animation, will have to deform the mesh corresponding to the skeleton. So now we need to define which areas of the mesh correspond to which bone, and also transitions between those bones. So okay, there you go, that's our result. So we have our rigged model and skinned model for free. You can see that it's even doing funny things there to the hands. Even though it's a simple mesh, so that little extra density of the vertices helped us there. So we're okay. And now we can download the original T-pose. That might be handy, just to download the kind of a basic version with just the pose of okay, character 1. Let's show me this folder. Character 1 bx cut d dut project git animation assets. Again, you don't need to worry about it. Let me just paste it so we can work with it. So character T-pose. Okay. But what the fun thing about Mixamo is that there's a whole library of animations. So jumping, samba dancing. It's really cool. The animations are super high quality, and most of the cases, like, you can really get some nice result with it. So feel free to delve into this library and pick whatever you need for your little narrative or cutscene or character controls. What we need now for today is a walk cycle. Actually, let's start with idle cycle. So just typing in idle and see which idle version I like. This one is okay, it's a kind of an alert idle. So I just download this, and here I can specify some parameters, such as frames per second, whether there's a keyframe reduction, and skin yes. Okay, so I've got that. Now I'm looking maybe for a walk cycle. We need to pick some walk cycle which we're happy with. This is a kind of with a bit of a swagger. Great. Important thing for exporting walk cycle, you see that the root node is moving, so we don't actually want that. So we check in place, and this is more what we're looking at, because we want to loop it and we want to control the actual movement of the character separately. Anyone attempt or do a character controller on their own already before? A character controller, like, so yeah, movement, state machine using Mecanim, like maybe you have done it already. So so if not, then we'll just get to this really quickly now. So now I have my walk cycle. I can download that again. Quite happy with this. Another trick is, okay, we need a left and right strafe, let's say. So let's look for something that's appropriate. There's all kinds of climbing animations. Let's see if I have anything that would fit a step to the left. That's not too bad. That might work for us. So download that. And then, unless there is a corresponding right strafe animation, perhaps you want to use a mirror. And this would generate the kind of mirrored animation, which is very handy. You can also control a couple of other things, like change the arm space, trim the animation a bit. That might probably mess it up a bit because that changes the looping. Overdrive, kind of exaggerate the motion or maybe speed it up. Different animations might have different parameters exported. So anyway, that's the basics of using Mixamo. That's really all there is to it. There's an interesting tab, animations, here, which also allows you to, characters, which also allows you to pick from different existing assets. So you can actually export that as well. But let's get to our Unity project, and let's import that package that I gave you. So go to Assets, Import Package, Custom Package, and I think it should be so I exported a couple of animations and with the corresponding model. Once you import it, they should all appear under the models folder. Success! Everybody up there with the models? Okay. All right. So let's start with the idle pose. Let's just drag our idle model into the scene. And there he is, or she. What else do we need to create a character controller? Well, for animations we will need, and there's a couple of pieces of the puzzle. Actually, forgive me, I missed a thing that I wanted to show you. So what I did want to show you before we move on to that is let me import this into Blender again. So the result from Mixamo, so you see that this is a version of the character which has a belly dance animation. So this animation is now added to the FBX file. This stores both the mesh and the skeleton, everything that goes with the animation. The way to deal if we need to do something in Blender, like for example, if at some stage you decide to make an octopus, and then Mixamo isn't much help because then you are dealing with a different skeleton for it, or different armature. then you have to go in and do some things manually, like even creating the whole skeleton from scratch. Now, I probably won't recommend this for this project, but you might need to do that sometime in your life. At least to get, only if to get a better idea of how to work with it and what do the artists have to go through. So what I wanted to show you about skinning here is you have a view which is called, okay, let me just select, which is called weight paint, and now this allows me to select any bone in our skeleton and see what is the corresponding area on the mesh which is controlled by this bone. And you can kind of see that the right up leg and the right leg overlap slightly. So there's this knee area which now here it's been painted over in a way that you know, this corresponds, this color corresponds to a number, and this corresponds to information given for every vertex. So say this vertex is entirely controlled by this bone. You can see, well, this one is probably going to interpolate the position of this bone and this bone. So this is how this mesh deformation is defined, and you can paint it yourself. Like if you do something silly, like let's say we keep this playing just to we can paint this on the fly, and let's paint the head with the weight for this bone. We see that this is totally messed up, because now this bone from this the thigh bone is controlling parts of the head. So that's pretty disturbing, but I think it demonstrates very well how the whole thing is coming together. So okay, so that's what I wanted to say about skinning actually and weight painting. This is where you would do it. Blender gives you some tools, basically painting tools. It's an art in itself. It's pretty tricky to get it right. So going back here, we need an animator component. There's a, take note that there's an animation component as well. This is an older version, which for some reasons still some devs might want to use. Let's not go into that though now. So the animator is here, and you see the first thing it asks for is an animator controller. So this is an asset. This is actually an asset that you need to have in scene. So let's make that asset. Let's create a new one. Let's create a new folder called animations. Animation, and let's create a new asset, create animator controller, and let's call it the player controller. This is where we're getting into Mixamo, sorry, Mecanim. Animation controller tells your object which animation to play based on some conditions. So how do we specify this? This is basically a flow chart, a state machine. So you have some states and you have transitions between them, and your script can control those transitions using parameters. So this is how it all kind of comes together now. So we'll make a very simple take of that on that. So let's create a new state. Right click here in the empty area and create a new state. Let's call it idle. Alright, and we select motion for it. Now all these motions exported from Mixamo are labeled mixamo.com, which doesn't help us a lot, but here you can see the file name might be more telling. So let's find that idle state. I think idle 3, no, there's an idle, okay, so we pick this one. And what else we need on this? Well, let's see how that works. So controller on animator, we select player controller. Okay. And now if we play this, taking a while, please. Come on. We see that our idle animation actually played, but only played once, I think. Let's see again. Watch this state here. No, nothing. Oh, actually I did, and it finished. Let's make a transition from this state to itself. I'm highlighting the idle state now, and just checking, okay. And I'd like this to have a transition based on a parameter called, I'm creating a new parameter now, a type rule is walking. So if is walking is false, I want this to transition back to itself. So we see that this now is looping. So another important setting, by the way, interrupt me if anything is unclear. Like, I don't know, some of you might have played with some of it. There's a lot of parameters involved. But this has exit time is an important parameter that you have to keep in mind, because this means that it's not looking at this condition until it has reached a certain stage in its animation. So if I have this has exit time here for this transition, it means that it will wait until we're somewhere around here in this idle state, and then we can loop back to the beginning. So we see that it goes through our whole idle cycle as we want. However, if we want to make it move, let's create another state. So let's create an empty state called walk forward, and make a transition to it. Now remember, you have to highlight the transition to set up the conditions for it. So if this is true, then this will happen. This transition will happen. So what do we want here? Is walking is true? Yes. If is walking is true, then we want to move to this state, and this state has a different animation associated with, which is walking. Okay, so let's try that. So we're in the idle state, and now let's force this parameter to be true, and our character starts to walk and then stays in this state. So again, we need to transition back to itself to create this loop. Highlight the transition, add a condition, is walking, is true, has exit time, yes. So hopefully this will work for us. Now I'm toggling this parameter, and it enters the state. Of course, you can see that this parameter should be controlled not manually but by script, so we'll get to that soon. So let's actually get started on that. Let us add a character controller. Anybody worked with this component before? Probably. Anyway, what it gives you, and since it's there, let's use it. What it gives you is a capsule collider, which you can kind of flexibly adjust to your model. If you remember, like, that was the whole idea with physics, was to like represent more complex things with less complex things for the purpose of physics. So I'm making a kind of a rough approximation using this capsule. You can read more about this character controller if you hit help and reference. At the moment it's not doing much, so we are going to create a new script to control our characters. So create a character script. Feel free to give me a shout if I'm going too fast. Okay, I've got a character script, and let's edit that. Okay, so our character, we will need a couple of variables for it. So let's start with adjustable movement speed. So let's make it public. And default value of 1. We will also need to access the animator. So private animator also need to access the character controller. So, having those variables for the references now in start method, we can assign them. So character animator, get component, this should be second nature by now, animator, and character controller. Same thing you do with any other components that you on an object that you might need to modify by script. Like a renderer or a collider. So now we've got that. And now let's go to the update function and get a basic input. So let's make a local float variable. Input, get axis, and the axis name default, since we haven't changed anything from default input manager settings, is horizontal, capital H, and same for vertical. Now horizontal is going to be the left-right movement, vertical is going to be the forward, backward. We will use, for moving our character, we use a handy function that the character controller gives us, named simply move. Now we'll need a vector, it needs a vector, so move vec. This variable doesn't exist yet, so let's make one. Vector 3, move vec. Oh, okay. Must have been mistyped. Yep, thanks for that. Okay, move vec. I need to change those hotkeys. Okay, we create a new vector 3. Thanks for being vigilant, because I'm recording this, so appreciate it. Horizontal for X, 0, 0F, and vertical. Yeah, okay. So we have a vector formed now, and character control. Now this is going to be pretty extreme if we leave it like that. We need to modulate it by what? Time delta time. And also, probably, since we created a variable for that, character speed. So this should allow us to tweak this movement to something that we're more interested in. Okay, so let's see the basics now. I'm gonna stick this to walking just to begin with, and just adjust the movement speed. So now I'm hitting the I'm hitting the W key, and I expect the movement to correspond to the animation. So this might take a little adjustment. I think 1 is not too bad. There's a little bit of like feet sliding, but I mean, nobody will actually tell. Maybe we should go higher, 1.9 maybe. See if we got something better. That seems to be actually better. So that's okay. So 1.1. All right. I'll rename this to player instead. I don't like the default name it gave us. Let me check recording is still happy. Yes. So character speed 1.1. Okay. So let's do the other state, and you know, this is walking state is probably not really what we want. So I'll delete this, and instead of yes, I'm gonna create a bool. I'm just gonna call them simply left, right, forward, backward. Cool. Create state, empty. Now let's also call them simple. Left, right, backward. And let me rename this one to forward. Now this idle state now and its transition. So this is a bit more complex. You can kind of imagine that there will be a lot of transitions, because from every state you might want to have different combination, and when we're in left we'd have to check whether we're still walking left or not and come back. Instead we're going to use this very handy state called any state, and this allows us to simplify our flow a little bit. It comes with a little bit of caveat as well, but we'll get to that. So first of all, from any state we'll add a transition to idle if, and now highlight this transition, and now add all these states. I'm just going to add this 4 times. Oh, come on, Unity, I want a little different layout here. Unfortunately, that doesn't make it nicer. I'm going to hit this like this, yeah. Left, 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 left. Let's just create the right conditions. This is the equivalent of an AND logical operator on all of these. So if left is false, and right is false, and forward is false, and backward is false, then we transition from any state into idle. So this should take care of our transition there. Does it need to have exit state? What do you think? Well, no, because if we stop walking, we want this immediately to transition to the idle state. Like if we're waiting until the walk cycle is finished, then we'd get a kind of a awkward result. So no. However, in this case, there's a bit of a problem. And let's see what's happening. You see that this is being spammed and is looping but too fast. So there's a problem. Actually, you would see it better if we had a different, longer cycle. but well, maybe let's try something with yeah, okay, so this is hip hop dancing, but you know, you see that something is wrong. So what's happening actually, it's this any state transition has a high priority, and it doesn't care if we're in idle state. This any state also applies, and this overrides this separate transition which has exit state. This actually doesn't have a conditions, so let's see if this we can fix it here. I think not, but let's see. So left, 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 left. I'll just duplicate this here. Just I want to have this distinction of having an exit state or not, an exit time. So false, 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 false. So if it wasn't for this high priority of the any state transition, this would have worked, but unfortunately this one is still higher priority. So thankfully this transition in settings we can uncheck can transition to self, and this will take care of the problem. So this any state now will mean that it won't transition to itself using this transition. So idle won't transition to itself using these settings. It will transition to itself using these settings. Okay, that's a kind of a, you know, it's a gotcha, and now you see that the animation is not it's not jittery again, and the only thing though, something is wrong. Left to right, if left, if false right. In this case, okay, this is probably what's happening there. There was a spurious transition, I think. Yeah, it's easy to go, and as you can see, it's easy to have run into problems. Left, right, forward, backward, if they're all false. And can it transition? Okay. Let me try again. Okay, sorry for this, not sure what I ran into right now. Perhaps it's something specific to the animation which is not looping itself, that is possible. So let me revert back to the idle that we had. Yeah. No. Oh, something parameter doesn't exist in controls. Okay. Oh yeah. Okay. So we had an empty parameter which was messing me up. Okay. So that's lesson learned. Be careful with those empty, unconfigured parameters. So now it's okay. So our idle cycle is looping. It's subtle enough, so it's not immediately obvious that it's kind of looping. I mean, it is, but okay, let's not overcomplicate things. Let's create a little extra code there. So let's start with the forward-backward movement. So we have a reference to our character animator. Let's use it. Let's see what function it allows us. Set bool. This is the function we need, and this will allow us to set a parameter. So our parameter is called forward, and we want to set it to whether we think that the character is moving forward or not. When is it moving forward? Well, when vertical, so So this is going to be a logical expression. So vertical is larger than 0.1. So this is kind of a dead zone. I don't want it to be 0 exactly, because with a joystick maybe you will have a small value spamming the input axis. So I just added a dead zone in there just to be safe. And so this expression in the parentheses will be true if vertical is larger than that value. And I'm going to do something similar for backward movement. I think this is how I named those. Yeah, forward and backward. And this condition is going to be less than negative 0.1. Clear enough? Very simple, right? So let's go back here to Unity. Oh, come on. So now this forward, so from any state we want to transition to forward, and the condition is, you should know, it's simple, forward is true. And this transition doesn't have an exit time. And in settings, it cannot transition to itself. I think we've already proven why we need to do this. So now let's okay. Let's do the self looping transition here with an exit time. So this would make sure that the loop only exits back when it's ready, so when a certain stage in the animation has been reached. And we do the same for backward. Make transition to backward. Okay, conditions. Backward is true. Has exit time? No. Can transition to self? No. Make transition to itself as a separate transition. This one has an exit time. Cool. And condition is, again, backward is true. Okay. So, very thankful for this any state, otherwise we'd have to have a lot and lot of arrows there already. So now I'm actually already moving. I didn't do something necessary, which was to actually specify an animation for the backward state. So walking, again, looking at the file names, walking backwards, I have this file here. Gotcha, try it. Okay, for some reason it makes me think of Portal. I think those little characters in Portal were a little bit like that, so that's not a bad style at all. Okay. One nice thing here that Mecanim does for us is blending between those animations. So you see that there's no like abrupt transition between different animations. So quite a lot of complex things are actually happening under the hood there. Cool. Let's continue. We don't want to mix the left and right with the forward and backward, but let's do it in a simple way at the moment. So let's do the same thing for left and right. So in this case, the horizontal variable has the values for us. So left is going to be, actually this isn't correct, so I'd have to swap it around. So right is when horizontal is more than 1/10, and left is when the horizontal is less than 1/10. Okay, so let's see. Cool. We haven't assigned the animations yet, so let's do that now. Come on. Yeah. Left, which motion? walk straight left. The naming of the animation clips is annoying, and what one would normally do is probably rename it in Blender or whatever, just to not to have to guess, but okay. I guess it's Mixamo product placement. So we've got left and right. Let's make the transitions, easy peasy. Has exit time? No. Okay, in this case left is true, perfect. In this case right is true, perfect. And now the transition back and the transition back. Okay, left is true. Has exit time? Yes. Okay, in this case no. Yeah, yes. What we missed out is can transition to itself? No. And here, can transition to itself? No. Okay, and now this add right is true, has exit time. So I think our animation controller is actually ready. Okay. It might still have a little bit of a problem, so let's see how that actually works out. Yep, right, left. Now you see there's a little bit more of a feet slide, so perhaps we actually need to vary the scale between horizontal and vertical. Now the problem is, now if I actually press the A and W key together, something funny happens because those two animations are now blended. There's a transition and it kind of goes between the left and the forward state, so we don't want that. So let's make it a little bit more elaborate. In this case, if, what's the condition? Like, can you kind of already see where we're going with this? So vertical is the forward backward movement. So let's say if vertical actually is within the range, so if vertical is less than 0.1, so if it's within the dead zone, actually end, sorry. Which is to say that we're not walking forward or backward, so we're within the dead zone on our vertical axis. We do something, which is we do exactly what we were doing before, left or right, and we check that. But if we are within that, if we are outside of that dead zone, so else, we will just set these to false. So right and left will be set to false, just directly. Okay, well, I hope you can, you're kind of up to speed as well. And let's try that and see how we did. So now if I actually press both keys, then I will just use the forward animation. It's a little bit limited, so again, devil is in the details, but I mean, this is workable. If we just strafe, then we use this animation. If we move forward, then we use this. If we move backward, we use this. And here's the state machine, which transitions between the states wherever necessary. Okay, any questions about this? You can see how you can already work with this to create something for your final project. What's probably necessary is some slightly smarter way of turning the character, because right now this would be only good for a game in which you only move forward or to the side, which is quite limited. But I'll let you think about that. For those of you who are not interested in learning Blender, I have actually a quick fix for you. Paint 3D, Microsoft Paint, the new iteration. Which gives us 3D shapes creation. Why the hell not? Okay, that's my head there. Okay, 3D shapes. Okay, select thickness. Okay, maybe let's make a body. Oh, I don't like that. Okay, and something with a larger thickness. Okay, and again, arms. This is how it orients itself in 3D space, so this might be a bit limited. Okay. It's a poor man's 3D modeling package, but it's, you know, it's cool that we have something like this. 3D shapes. Let's finish it off with a bunch of arms and legs. Okay. Well, this is really horrible. What we can do from now is go to menu, save as, and voila, we can select FBX there. So this is the impressive part that they bothered. The problem with this is that you have to check the geometry that you receive at the end. So let me actually load this. So I'll import this FBX really quickly. See what we actually get. It's very small, so I first of all need to scale it. I'll actually scale it 10 times or 20 times. Okay, cool. Alright, and let's have a look at the geometry there. You see that you know, everything looks okay, but the arms here like have very long edges, which would cause us problems if we use this in Mixamo. Let me actually quickly prove it to you. Let me check the size on this whole thing. What is it? Come on. Well, first of all, it's a collection of separate meshes, so that's a little bit of a problem. I would like to have them merged into a single mesh. So I'm selecting it with a shift key pressed, I right click, and now I press Ctrl J. Join. Oh, what did I do? I think something happened with scale there. I don't believe that I've lost everything, hopefully. Let me select everything, Control A, location, rotation, and scale. Okay, and yeah, okay, so now I've joined it. And let's export the result here. Have a quick look back into Mixamo. Might take a second. Okay, let's say that's what it is. I'll break symmetry because this is definitely not symmetrical, so it won't help. Wrists, elbows. You probably can start seeing where I'm getting at with this. Oh, right. Cool. Remember, the hands were just a very basic tube, which was the sides of it were long polygons. And remember what I told you about skinning, that the information about weights, that the assignment to individual, you see that what happened to the hands, they're not very expressive because there isn't enough vertices on the hand. Oh no, oh, I just cancelled out of it. There isn't enough there isn't enough vertices to correctly express the entire animation. So okay, sorry, I have to quickly do this again. Okay, next. Okay, so let's try any animation. You see, this should be doing interesting things with the hands, and it's not. The hands are quite rigid and they don't bend at all. There just isn't enough vertices to express elbows. So to fix that in Blender really quickly, I would go for a quick fix like this. Go to edit mode, deselect all, so A key. Go to edge select here, border select, okay, mesh, edges, subdivide, and I would just max it to 10. I think 10 is the max that you can do here. So that's fine, and now again do the same for this hand. Subdivide. Alright, and actually that should do the job. Export it really quick. I hope that went through, yeah, that did. So there you go. The density of vertices is quite important for animation. This was like a very extreme example, but this is where it comes from. That's why your artists need to constantly trade off between the articulation of the mesh and the efficiency, because we don't really want super complex meshes everywhere because of performance reasons. So well, when you look at it this way, it's quite amazing that we can just in half a minute create something out of nothing using Microsoft Paint and have it rigged automatically and just plug it into, like, you know, would have been unthinkable a couple of years ago, you know, so count your blessings as an indie game developer, and see that elbows are bending properly. Now we can even go for a sexy belly dance. Yay, okay. Alright, so that's enough of Mixamo for today and Microsoft Paint 3D. I just wanted to show you like an alternative if you really were scared of Blender. And we'll move on to a little bit more detail about animations. Do you need a break? Should we go in? Yep. So let's actually have a look at what did Mixamo create for us in terms of animation clips. Maybe like as an overview, like if you're not importing your animations from an animation package, 3D package or Mixamo, you can do some simple animation using timelines. So timelines is another big topic there. This is somewhat trying to bring Unity closer to like a movie editing software, where you can have a you know, a certain sequence of events, closer to like motion animation, motion design. So let's see how that works. I'm gonna save this scene. And now we're gonna call it timeline. We're gonna do something more interesting maybe. Let me create a plane just for floor. Reset it. Scale it a bit. Make a quick material. Cool. And let's add a 3D sphere. Let's make something a bouncy ball. Just need to cut in there. Yeah, okay. Orange. Okay, an orange ball. Let's move the direction of light. Everything is kind of facing backwards, so let's make it friendlier looking. let's make our guy blue. Blue and reflective. And maybe let's just hack this player controller. Let's make a new one. Belly bands. Alright, open. We just want one animation in there, so create state empty, yep, motion, I think the first one, yeah, there we go. And just a transition back to itself, so has exit time, yes, condition, no condition, so this should be automatic. Okay, another thing we need to do, of course, is change the controller to our new one. Not very interactive, but okay, something is happening. And now let's animate the ball. So go. Let's go into our animation folder and right click, create a timeline. My timeline. So timeline, again, like a player controller, it's also an asset, so it's independent of the scene, so you can edit it in player mode, play mode, or in editor mode, and switch back between the modes, and your changes will be saved anyway. So maybe if I forgot to mention that, they're external to the scene, right? The important thing though, they need to have bindings to a scene for this to work in a scene. And this will probably catch you out at some stage. Let's create a new object called timeline. Also, let us position the camera differently so that we have an initial starting point. Maybe a little closer or something, I don't know. So we're getting toward getting something like a rudimentary cutscene. And let's see how we do that. Oh. So I'm putting this timeline object separately to the rest of the scene because I might need to animate several things. So let's add a special component called playable director. So this is what you need to start with to be able to work with timelines. And playable director, like remember the animator needed the animator controller plugged into it to be able to function. Well, the playable director needs the timeline. So let's plug this asset in there. And yeah, and now we can open this timeline. It's important to have this highlighted. This way we know that we're on the right playable director with the right bindings. Now we can add an animation track. But to do that, like let me try that now, and I can only select the player character there. Why? Because only the player character now has an animator on it. We need an animator on the orange sphere as well. So let's actually remove the sphere collider from this. We don't need it. And let's add animator. We don't need a controller for it. We're actually going to override it with timeline. So this is kind of the slightly different approach. Let's see how it goes. highlight the timeline again, you see that it points to none right now, but now we can select the sphere, and that's good. Okay, now let me maybe move this down so we can have a bit more room for the actual timeline. There's a record button in here, so you can record what's called like an infinite clip. And let's try it now exactly. We're at the beginning of our timeline. Let's have a look at the cog icon here. It allows you to specify the units, so if we switch to seconds it might be a little bit easier to work with. And let me just give us a orthogonal view, because we need to be somewhat precise. And let's move to timestamp of 1 second. And let's move the ball. Oh, I moved the wrong thing, sorry. Also, it's advisable maybe to freeze this timeline thing so we don't change things too much. Okay. Okay, I moved the ball up, and you see that a keyframe appeared. So Unity is now tracking what we're doing with the ball and creating keyframes based on that. So now I move the timestamp to the beginning again at 0. Okay, so now I've captured some kind of a simple movement. Now go back to 2 seconds time. I'll go to this stage again, and we already have our little animation recorded. It's pretty poor, but you can see that Unity actually helps us a bit by smoothing out the curves, so there is a little bit of a easing, so what's called easing in movie editing. How do you control it? Well, you can right click on a keyframe and select for both tangents I want them to be linear, for example. So this will create a much kind of like cruder transition. You see that there was no kind of a easing, smoothing there. If you go to auto, it will allow you to adjust it automatically to smooth curves, Bezier curves. Okay, but this is a bit boring, so let's go back to the record mode and let's work on the scale a little bit. So let me actually go back to the beginning and scale the sphere vertically. Just squish it, maybe a little bit, and then move it again a little bit so that it touches the new squished ball touches the floor. Now we'd like to move up a little bit and unsquish it. Actually, I'd like it to exaggerate it so that it kind of goes into a wobbly state. You see that new keyframes are being added. Then a little while later, I want the ball to be already a perfect sphere again. So let's call it that. You can see on here on the curves that I'm hitting 1 again, so that's okay. And I'd like to do the same thing on the other side. So again, we go back to our endpoint. Endpoint here at 2 seconds. Squish it. And I'd like to hit the same scale that I had on the other side. And move it down. Okay, unsquish it. And return to normal. Roughly, anyway. Yeah. So let's see how that worked out. Okay, that's not too bad. Now to actually loop it, let's go back to our timeline, and there's a wrap mode setting. So let's say set it to loop. And let's play it. Okay, so that's kind of like a beginning of what an animator might be doing in their 3D package. We can now do this stuff in Unity. What's interesting there is that now we can convert this to an animation clip. Convert to clip track. Okay, and if I click edit in animation window, now it opens up a more precise animation clip editor, which shows me the dope sheet, which is here this time series of keyframes with different parameters changed. We can actually add properties, so we can change rotation, change stuff like color, for example. So feel free to explore what else can be animated. And you can switch to curves, which gives you this graphical representation of what's happening with each individual variable. And here also you can control the what's happening with the smoothing. So maybe at some stage the smoothing is too hard and it does something funny to your motion. Well, in this case you can correct it here. Just for comparison, let's see what we got from Mixamo. So let me open the animation window. Remember, the player character, or the one that we're interested in, needs to be highlighted, so then the animation knows what object we're talking about. So this Mixamo clip is read-only, unfortunately, but already shows you one of the big issues with animation, which is there's a lot of data, especially for a complex skeleton. So not only these keyframes all have different information that conveys all this dancing motion, but effectively in game some of them are actually interpolated, so they are smoothed between this keyframe and this one. This needs to be smooth using maybe Bezier curves, whatever this transition is. So you can kind of imagine there's actually a lot happening under the hood, and that's what skinned renderers do there, and the animation controller. So if you're animating large crowds and a lot of characters, at some stage you need to think about optimizing your animations, and that's another big thing that the animation division of your studio needs to take care of. That this is not gonna all end up in 10 gigs of asset data just for animations themselves. So that would definitely be a no-no. So yeah, this is what we got for free from Mixamo. So yeah. Any questions so far? All very clear? No, very clear and simple. Is it all very familiar to you? Have you used all of this before, or is some of it new, or all of it? Okay, well. Okay, so let's try what else the timeline can give us, because it's actually an interesting component, asset. Like I said, it's a little bit like a movie editing capacity. So let me go back to timeline here. We can add an audio track as well. Bingo. But now we don't have an audio source. We can just plug in an audio file in here. Let's see. So let me plop some music in there. Well, let's have something with a bit of a beat. Okay, and we need a audio controller or audio source in the scene, which we right now don't. So let's place one maybe on the main camera. That's not the worst place you could have it. Audio source. For kind of omnidirectional sound or something that is you know, always there, then that's okay. So let's select this object. Now we have a binding in the scene, and we have this audio track here. Let's try it. So something with definite beat, and let's try to match things up. I'm just plopping this onto the timeline itself, and let's see what's happening. So one interesting thing here is this clip basically played once and stopped. Is this what we want? Probably not for this case. So I'm now highlighting this this track, actually this clip here in the timeline, and it allows me to select some things with more precision. One of them is animation extrapolation. So this allows me to specify what happens when the clip ends. So it either can hold its position until infinity, or maybe I can ping pong it or loop it. So in this case, it should be a symmetrical enough clip, but I think maybe ping pong is safer, because if there is a mismatch in the scaling that I did in this animation, then this should actually cover it up. Something is happening now. What can we do with this speed here? Let's have a look at this clip again. You see that there's a speed multiplier here, so actually we can make it more lively. So didn't work as I wanted it. Okay. Well, one obvious thing, I don't know if you've played with this before, but there is a in preferences. No, sorry. In time, in project settings, you can actually scale the time. So let's actually play with this. This sometimes is handy when you want to pause the whole game. But it's a pretty crude way, like, because it affects everything. So you know, use with caution. And also, you notice that it didn't affect audio at all. Like, that's one of the problems with the timeline, that you know, so things like pausing and pitch, you have to take care of it yourself, and they didn't actually implement it, which is a bit of a shame. One reason is that the audio handling is done on a separate thread, I think, and you know, it's just not integrated well enough. You can implement it yourself, but then you need to go into what's called playable interface. So there's quite a lot of complexity before you can actually get started with that. Let me kill all that. So let me just see if I can recall what else can I do with this. Well, hopefully I can actually do something with a clip in animation editor. I'm not too sure. I mean, I could squish it all, but no, not really. I have a feeling that some of this interface changed since you know, maybe when I did the in-depth timeline work. So I'm not convinced why it's not. Let me just kill it. Yeah. Oh, no. Okay, I'm zoomed in too far. Okay, so this actually works here. I suppose it's not editable on the fly, so let us do 2. Or maybe it has a problem with let's see. So yeah, it doesn't work at play mode, so in terms of matching this to the music, I'm not sure how many beats per minute that track has really. I'm not a DJ. Okay. Alright, I know what I've been doing wrong. This clip needs to be individually selected to be able to edit it, so that's what was wrong. Because I can have different instances. I can have different instances of this clip and maybe with different speed multipliers set on timeline. So it would take a little bit of a trial and error. I mean, I have a thing it'll be something like 120, but I might be wrong. 2 seconds. That's way too fast. Way too fast. Okay. Sorry, making the same stick again. Bad roll. Let's say it's close enough. So now, what else can we do that could be actually useful for us for our cutscenes? Is animate our camera and make some little bit of lively cinematic action there. So for your game, perhaps you want to have several cameras that you switch between, like one would be tied to your player and another free floating, and you can switch between them, or maybe force that switch when you are triggering a cutscene. So let's just work with this one, and since we have a static setup. So okay, what do we need on the camera to animate it? Which component? Animator. Okay, we don't need a controller. All this is okay. Add an animation track. Okay, and let's try to design a little bit of a motion graphic, like a cinematic. So let's say this is our starting position. Camera is right here. Come on. test. Okay. So at point 0, we started this place. Cool. Let's maybe move the camera a little bit so that we generate a keyframe. Just kind of a hacky way, but let's just make sure that we have a keyframe in the beginning. And let's maybe do a 5-second dolly. Or first, let's move to 2 seconds. So let's start static, or very gentle movement forward. Okay, and then we zoom in onto our dancer. So we can either rotate or like kind of like do a pan. I think the best choice here would be just to kind of position it until you're happy with the position. And then tilt it up a little bit, maybe. Okay. Alright, so we can hold it until we're at 5 seconds. Let's move it just very slightly so that we have a keyframe. And let's do a very slow movement to get the whole scene out. Okay, let's see what we got out of this. Convert to clip track. So now we have a recorded animation clip. In the properties, post extrapolate, let's say we ping pong as well. So this, I'd like this to go back and forth. Why not? Let's see what we got. So I think enough to get started. Other features of the timeline that are useful sometimes are activation tracks. So this will allow us to turn on a certain object or off. So let's, for example, add an extra light to the situation. Maybe a spotlight. Okay, and let's move the spotlight up a bit, make it more intense. Let me just see it in the scene. So that'll be a spotlight on the dancer. Okay, again. Alright, and let's maybe animate the, let's see first what kind of effect we're getting on this. This character is pretty shiny, and so we won't get much scatter off of it, so let's change that now. blue material. Since it's so reflective, it doesn't actually have lots of diffuse off of it. Like it's kind of yeah. So in order to actually see the color of the light on it, we have to make it more diffuse. So that's what I just did. And this activation track, now I'm gonna plug in the spotlight so that this light only activates here. So let's say we start with the spotlight switched off. And it will turn on around the time when we finished our first camera move. Okay. I think I need to be a bit closer there and zoom it. So that would be particularly handy if you have some large bit of geometry that only is visible after the camera moves to a certain location. So then you want to enable, for example, interior of a building only after the camera has entered there. That'd be one way of making sure that your performance doesn't go to hell. So I'm going to just use this activation track, and another thing I can do is animate. I'll animate the spotlight as well. So this is a little bit maybe of a duplication, but I will add an animator to this, which allows me to now add the spotlight here and record I'll start with the intensity at 0, and this already creates a keyframe here at this location. Now just before I activate the spot beam, I'll create another keyframe. Also 0, and then I want to have a fade in, so go from 0 to 1 over the course of this time, and then on the way out I also want to maybe animate this a little bit from 1 to 0. Okay, and additionally, so I'm going to convert this to clip track now. Stop recording, double click it, and I'm going to animate a bit more about the light, animate the color of it. So I'm going to go to this keyframe here. So this is my kind of interesting area where the light is already switched on, and I'm going to add a keyframe. Now if I do this while I have everything selected, it generates the keyframes on everything, but maybe I want to just create a keyframe on the red component. Oh God. Sorry, what did I do? Yeah, okay. I think this is because the object isn't active, so that causes a little bit of a problem maybe. Let's delete this and record it again. I'll go here. Okay. Maybe just move a little keyframe. This is like next frame. So you see that now everything seems okay, so now I can actually do something to the color. Okay, I'll go from orangey to, let's say, yellow, and then to blue. Purple. And I think that's it. Convert to flip track. Okay. If we want, we can adjust stuff. Okay, not sure. Okay, there it is. We've got our curves on the colors here. So just like we did with position, all this can be applied. And here you can see the red, blue, and green changing in time. So let's try it now. Okay. I didn't really see a lot of change in this light, I'm afraid. I just think it's just the material that's not very good for it, so let's modify it even more. I'll make it white albedo. I'll actually decrease the directional light intensity overall for the scene. Okay, and that should be much better. So okay, and the metallicness, yeah, that's fine. And another thing that I want to change is the camera, the camera field of view. I want to make it a bit more fisheye. Okay, so with the ping pong off, it was very interesting. Anyway, you get the idea. Okay, so maybe let's take a 10-minute break. Okay. Cool. So let's get on with the show. I'd like to, one last thing today I'd like to go through is animation triggers. So there's a difference between a standard Boolean parameter and a trigger, that the transition trigger is consumed by it's consumed by the transition. So I will make it a bit more clear now. Let's save this scene now as something different. I'll save it out and let's save it as a trigger scene. And let's make something slightly different. Let's get rid of this ball here and all that's happening to the ball. Timeline, yeah, actually let's remove all this. Let's delete the animation stuff. Let's remove the spotlight and let's make something which is a bit more like what you might need for an interactive game. So let me close all this. Let's remove the sphere, delete, and let's duplicate the player character. Is it, yeah, is it faint or? Okay, sorry about that. Yeah, I was muted. Okay, really sorry. Thanks for that. Okay, so, okay, sorry for repeating myself. Now we're gonna save this scene out as a new scene. Save, remove the timeline object, remove the spotlight, and we're gonna play with triggers. So let's make something that might be handy for a little adventure game. So let's see, let's duplicate our player character. Okay, and move it into a different location. Obviously, right now they're both controlled by the same player controller. Oh, okay, it's not the player controller; it's the dance controller. So that's another thing that needs to change. The main player, let's. The main player, let's revert it back to the player controller on its animator component. And let's rotate the other player so that they're facing the main player. So this is NPC. Okay, and let's create a sub-object here, a little sphere for a zone. So remove the renderer from it, leave just the collider, set the collider to a trigger, scale it a little bit. Okay. Okay, at the moment what we should get is one dancing character and one moving character. Maybe let's move the camera so that we have a bird's eye view of the whole thing. Kind of a third person view. Yeah, that will do it. Okay, let's make it, let's actually duplicate this belly dance controller. We don't really want to destroy what we had there, so let's make it another NPC controller. So let's call it NPC. And let's enter it, and let's make a couple of states. Let's make a kind of a looping sequence of states. So first one, maybe let's be state 1. Let's make another one. State 2. State 3. Let's remove this transition now. Well, actually, no, that's actually fine. This transition is fine. So unless otherwise, this is an empty condition list. So It's an empty condition list, so this will loop on its own. Let's choose a different animation there. So let's go from hip hop dancing to another state is going to be idle 2 and pick whatever I want for the third one. Okay, and now create transitions so that it forms a loop. Okay, so let's define those transitions now. Has exit time. No, I don't want this. I want them to be immediate when we need it. So otherwise, because those dance loops are pretty long, then we might have to, wait for too long before we can actually have some kind of a. Let's make a self transition with an empty list. Has exit time, yes. Yeah, same thing here. Okay. Sorry. And add a trigger. So that let's call it let's just go trigger. So yeah, if and all we need to do is just say okay, trigger. Yep, trigger and trigger. So this actually should be pretty simple. What's going to happen? Okay, we start, entry state goes into state 1. So this hip hop dancing thing ensues. Okay. And those transitions don't have exit time. Yeah, okay. So now we'd like to add some little bit of a logic to make things happen. So on our target sphere, let's create a small script. Now this NPC has a character and character controller, which we don't need. So let's remove this. Let's remove this character controller. And actually what might make a bit more sense is have the sphere mesh directly on the NPC with the animator. So I'm actually going to add this here. So I'm going to add a sphere collider here and remove this. I think this should also be the reason why I do it. This should be kind of clear for you. Remember what happened with the our turret controller. So we had the collider on the same scene node as the actual turret. We were able to do things immediately. So let's do an NPC script and make it react to our character. Our player has a character controller with a, let's see how that works. So let's edit that script. So on collision enter, I'd like to do something, and that something is we need to have a reference to our animator controller. So private animator NPC animator, and upon start NPC animator get component animator and no parameters. Okay, so we do nothing on update, refine, only on collision enter. Sorry, not on trigger enter. I prefer the auto trigger enter. Prefer the trigger to the autocomplete to give me the right argument. So now we have the other collider. So if other tag equals player okay, we do something, and sorry, that's a equivalence operator, not an assignment. So two, yep, and we need a reference to our animator. Set trigger. Trigger, and well, let's see if that works for us. And this will depend whether the default, let's see. Okay, parameter left doesn't exist. I'm not sure this is either an old, let's see, player. This is okay. Let's see. This is my game. And let's have a look at our NPC. Oh, I didn't assign the right controller on it. NPC. So, what's happening? At the moment, our hip hop dance carries on. And nothing happened. This might be because there's no rigid body. And remember about, do you remember about the triggers? You need one object to have a rigid body on it. doesn't seem to get fired. Okay, apologies. PC scripts, let's have a look what's going on. Let's add a debug line there, just to see if this is even PC. Oh, this one hasn't been checked to its trigger. Okay, and also I think the size is not correct. Let's have a look at gizmos. So yeah, that's my bad. I think actually that rigid body is not needed as well. So the radius now, let's increase the radius to this. And let's see what happens then. Still not working the way we want it, unfortunately. And unfortunately the console is not registering the that's another thing. Player, we haven't added the tag. Okay, well anyway, we're practicing, so let's hope finally. Okay, so triggered. It went into an idle mode. So here maybe you want to have other things happening, like triggering a dialogue segment. I'm moving away from it. And then the second time that I've approached the other player, it triggered another dance. So you can see, let's have a look at what's happening on the other player's animation controller. Let's move out of it again. And let's trigger that again. We went back to hip hop dancing. So this kind of mechanism might be handy if you want to say open an automatic door, trigger some piece of music somewhere, well in this case animation, so you know, lots of other things in the environment. So another way to make the city respond to you and make things more interesting. Perhaps yeah, perhaps give it a bit of expression to you know, the other characters in there. Start waving at you, or you know, being aggressive or whatever. Okay, any questions about this? If not, then I'd like to spend 15 minutes just playing with the things we learned today. Just use the time to, you know, just see if you can get a basic interaction like this happening, and I'll be here to help you if you run into problems. And then in the meantime, I'll think of something else to fill in the gap. I think I've again underestimated the speed at which we're going through things. So I'll give you 15 minutes. Please try to create a little bit of an interesting action there. Maybe you can actually show it through screen share. That would be interesting. Is that okay? Yep. Yep. Okay, but I mean, you have a starting point for like at least playing with it. Could you set up like a new scene entirely from scratch and just use the assets to come up with something simple like that? You can use the scripts. I'm kind of more interested in you setting up the timelines, animators, and basically running into maybe some issues. I just like to see a very simple setup. You know, a small in-class exercise. I've been talking for 6 hours non-stop now, so I kind of ran out of ideas at the moment, so that will give me a chance to actually think of something interesting to add on, so that we get the most out of it. So 15 minutes, please. Okay. Well, anyway, at least you've tried. So I think I'm going to add a little twist to this, because we haven't mentioned animation curves, a separate kind of a type of asset that you can have. And they can be your friend as well. So let's do something like this. On the player character, let's edit the character script. And let's actually add a coroutine there. So we haven't used coroutines before, or maybe you have tried them before. I don't know, did you? Generally in Unity scripting, the sequence of events is that, well, you do the start function, then you treat update as a bit of a callback, and the update function is called every keyframe. But then once you're doing something in the update function, nothing else is happening. With that object, it's like you couldn't have an infinite loop running in an update function, right? It would really mess things up, because everything would halt now. So the way to actually work around that is via something that is similar to multi-threading, similar to concurrent processing, but it's only make-believe. It's actually like a way of Unity to time multiplex the code that's being executed. So coroutines are actually a bit of separate code, which is being kind of treated somewhat separately, and it's being interleaved, and kind of like a little bit of it's executed, then we come back to the main loop, and somehow we have a kind of what looks to the outside observer as a separate execution. So to work with coroutines, you declare them like this. You need the class enumerator, sorry, and let's call it React coroutine. Okay, and then you add the body of the coroutine. Yeah, it needs to return. So what we're gonna do is have a little timer in there. So float timer equal to 00f, and then timer is equal to Unity, or maybe endpoint. Let me see. Okay. Float timer is time. Sorry. Time, I think, is a good way to do it. So we basically assign the current time to the timer value, and then while timer is less than, okay, we need some extra end time or something. Float end time let's say 3 seconds, let's just hard code it. This is just a quick example. So while timer is less than end time, we do this. We do again timer plus equals time delta time. This is just to keep track of the time, and we add an extra asset to our script. Public animation curve. Okay. Okay. The way to now, is it entirely new? Have you ever heard of coroutines in enumerators? You have, okay. All right, so I won't dwell too long, but it's good for to see for everyone. So I might have mentioned, I don't think we've actually used them. So okay. So all right, so let's spend a little bit of time on this. They're very important for things like you know, especially animations, UI things that happen, and we don't want to kind of mess up all our other order of execution in a program just to do some small little thing. So this is exactly what we want to do here is when the player enters the other player's trigger, we want to react. So maybe we'll do something to the material of the player, turn it red for a little bit and then back again, something like that. So let's see, and animation curve will help us with it. So we have this animation curve, any curve, and now let's say float value is equal to any curve, and then animation curve evaluate, and this is where you specify time. So this is between usually maybe between 0 and 1, but well, let's assume this is between 0 and 1. So how do we end up with 0 to 1 using our timer variable? Well, we take the difference between the end time, or maybe we take we'll divide timer okay, this would mean that we need to have actually start time. Anyway, I'm improvising, so bear with me. We can do it this way. So float start time okay, so we evaluate timer minus start time divided by, and then 3, because that's the interval that the entirety of the animation should play through. So I said, okay, we're gonna finish this effect. Okay, yeah. So actually, we don't need end time. All we need is start time plus 30f, and we can get rid of an extra variable. Like, why bother with this? And that should be okay. So this will evaluate to a value between 0 and 1 between those, like within the course of these 3 seconds, and we end up with a value. The value will come from our animation curve. And now another thing I'd like to do is actually we'll make another material for the player. Like really quickly, assets, okay, material, animated, any material. Let's start with this blue, it's fine, or maybe let's make it more like a slightly more realistic skin tone. Alright, okay, let's make it just non-metallic. Okay, cool. let's add a reference to that material in the script, so that well, we need to grab it real time as well. That would be probably best. So private material, my material. Okay. And upon start, we will retrieve this material. Okay, so my material is equal to, first we need to get the renderer, because the material is assigned to the renderer component. So renderer. So we've got the reference to our renderer, but now we need to pull the material from it. So material. This will do the job. Now my material holds the material that our player is wearing. And here in our coroutine, we're going to use the animation curve, and again, oh, okay, thank you. Yeah. Okay, so thanks for that. Okay, another thing about coroutines is like you do control these. You do control the time that the coroutine yields, so allows execution to the rest of the code. So this is how you actually do it. Expression usually I think yield return null. So if you have this in your enumerator, this means that every time in this while loop, if you reach this, execution comes back to the update there for one instruction, and then comes back. So that's the general kind of overview of how the coroutines work. So this now is no longer giving us hassles. So let's have a look at the animation curve instead. So we're on our player. And we have a couple of new things. So animation curve, and brilliant, we have a couple of ready animation curves for us. So you see the range of the output values between 0 and 1, which is what we're happy with, but we can actually make it any range of values. And also the time axis horizontally goes from 0 to 1. And we can select whichever curve we like and use that. So for small animations, without bothering to use... yes? Okay. Without bothering to use animation controller, this is a quick and dirty way to actually animate something. So let's this AnyCurve evaluate is going to actually sample this curve based on this input value. So this is going to be the time. So in a way, like the value between 0 and 1 will define what value from the curve we read. So what we'll do with this value now is, since we have our material, so my material color equals to new color. Actually, sorry, let's do it this way. Color, my color equals to my material. So to begin with, we grab the current color of the material. That's what we start with, the original color, the main color of the material actually. So using Unity standard shaders, that should be your albedo color. And then inside this loop, once we have our value, we create a new color. Probably the smarter way would be to just use what we've got here and modify this value. So my color dot r is equal to value. So this is allowed. I can just apply this changing value to the red component of the color, and then I assign this back to the material. Okay, so let's see how this works. Another thing that's missing is that we never triggered, we never executed our enumerator, our coroutine. We can just for now, let's start coroutine, react coroutine is all you need to call to make things happen. So this is going to happen upon startup, but we're going to modify it later. But let's just first make sure that it does something. So let's save this. And it unfortunately doesn't. There's no render attached to the player character. Yes, okay. Okay, because our actual geometry is below. So, sorry about that, but that's easy to fix. That's super easy to fix. All we need to do is just to explicitly have a renderer. So public render my render. And when we get the material, we could actually use the material as well, but many ways to skin the cat. Cool. And let's try it now. Since we have specified my renderer now as public, we need to assign it. So this is the cube. Yep. And you see that it went from green to red and then stopped. So that's what's happening. Let's make sure that this makes some kind of sense in game. So let's add a on trigger enter. So whichever collider we enter, we'd actually like to run this coroutine. That should, because we don't have anything else, so any other colliders, so this should actually be enough. I don't quite like, well, okay, the starting color is, let me change this animated material to something, it's albedo color. Let's bring down the red component. So that we actually start out green. Let's change the floor so that we have a little bit of a difference there. This is ugly as hell, but okay. Let me clear the console just to see if everything is okay, and go. So once we entered the other player's collider, two things are happening. The animation on the players changes, the NPC, and we have a little bit of a blush response on the main player. So let's recap. Let's have another quick look at this script, because you know this is new to you. So what happened is we added a animation curve asset This asset is cool because what we can do now is, as with any assets, and I kind of like keep talking about this over and over again, but we can, for example, make it blink. So we can make any kind of transition we like. It's good to actually save a new curve once we've done it, and this way it gets captured. So you see this happens a couple of times now. Now this is a pretty kind of unimpressive example. You could probably get a better result if you use the emissive of the material, but that might require a little bit more complications. So here we've got something happening. It's up for your imagination to fill the blanks. I will post this project as it is to the repo. I encourage you to practice setting up your own repository from scratch, and hit me up with questions about the final project. It's a good time to start thinking about what you'd like to do with it, and see what components and what skills from the previous part of the course you can bring to the game to have something, create something fun. So I think we're done for today. Thank you very much. Hope you have a nice evening. Any questions? No, you're good? All right. Good luck.